Hi, everyone, and welcome back to Organic Chemistry on YouTube. Today, we're going to talk about the oxidation of alkynes with potassium permanganate, KMnO4. So first of all, KMnO4, potassium permanganate, is a powerful oxidizing agent. It tends to convert carbon-carbon bonds, like an alkyne. It tends to convert carbon-carbon bonds into carbon-oxygen bonds. That's an example of an oxidizing reaction. This reaction is also pH dependent, so the outcome involves forming the carbon-oxygen double bonds, and what kind of carbon-oxygen double bonds are formed depends on the reaction conditions and the pH. So let's look at the reaction overall and a few comments on the mechanism. So if we started with a generic alkyne, indicated here with two R groups, one R and R prime, to distinguish the two R groups. And we reacted these with potassium permanganate at pH 7, we would synthesize this diketone. In contrast, if we use this terminal alkyne, if we use the same alkyne and treat it with potassium permanganate, but now in the presence of potassium hydroxide and a pH 11, pH 11 is indicating that this reaction is basic because of the potassium hydroxide, we end up with two different carboxylic acids. One, where we've broken that alkyne bond and taken the carboxylic acid from the left part of the molecule, and another one with R prime from the right side of the molecule. So if you use the strong base, so strong base is going to yield carboxylic acids, while a neutral pH will produce a diketone. What's good is that this is one of the few ways that we know to make a diketone. So when you're working on synthesis problems and retrosynthesis problems, you can use this as a reliable transformation to start from alkynes and end up at diketones. This reaction mechanism is far outside the scope of this course, so just knowing these transformations is enough. So some questions you might want to ask in office hour: does this reaction outcome change if the alkyne is terminal? 2, do I need to indicate pH 11 and a strong base? That's been Organic Chemistry in 5 minutes or less. Thanks for tuning in.